In this module, we're going to talk about molarity. All right, so we're talking about solutions here, so we have to make a few definitions so that we're clear as to what we're talking about. So when we have a solution, it's a homogeneous mixture, and there's going to be at least one solute, there may be more, and one solvent. Solute is the substance that's being dissolved. The solvent is the dissolving medium. So if you put some salt, sodium chloride, into water, salt would be the solute, water would be the solvent. If you're mixing two liquids together, then just whichever liquid there's the most of, that's the solvent, and anything else is the solute or solutes. So, definition, molarity, symbol is capital M, is defined as being the moles of the solute per liter of the solution. In terms of symbols, big M stands for molarity, N is moles of solute, and V stands for liters of solution. So with the definition of molarity, we can use it to find any one of the three variables given the other two. If we know the moles and the liters of solution, we can find the molarity. If we know how many moles we have or want and what the molarity is, we can find the volume. Or if we have the molarity and the volume, we multiply them to get the number of moles of the solute. Some notation here, when you see a formula for a chemical in square brackets like this, it's shorthand for the molarity of that stuff. So something in brackets means the moles of that divided by the liters of solution. So now that we know the definition, we can use it. You may recognize this stuff. We want to calculate the concentration or the molarity of the cobalt-2 ion in a solution that we make by dissolving 2.787 grams of this stuff, cobalt-2 nitrate hexahydrate is what it's called, in enough water to make 50 milliliters of solution. And if you look at this formula, you can see that in 1 unit of this whole thing, there's 1 cobalt ion. So, and it ends up that when we put that in water, the cobalt ion breaks away, so that we form 1 mole of cobalt-2 for every 1 mole of this cobalt-2 nitrate hexahydrate that we dissolve. We're going to need to use that. All right, so here we go. Start out with the definition, right? The concentration or molarity is moles of the solute, which is cobalt-2 ion, divided by the liters of solution. Well, the bottom part's easy because we already know how many liters of solution we made. Well, we made 50 mils. So if we just divide by 1,000 or move the decimal 3 places to the left, we get the liters of solution, 0.0500046 sig figs. And that's one part of the equation. The other is the top, the moles, right? So we know how many grams of the cobalt-2 nitrate hexahydrate we dissolved, so we just divide that by the molar mass. And we had already calculated this molar mass in the previous module, but it's good to review. If we're going to go to the periodic table, find the molar mass of cobalt, 2 times the molar mass of nitrogen, 6 plus 6 is 12 times the molar mass of oxygen, plus we're going to add 6 times 2 is 12 times the molar mass of hydrogen. And when you do that, to 3 places past the decimal, you get 291.034 grams per mole. So the mass divided by the molar mass, that's what we always do. If we want to find the moles from the grams, we divide the grams by the molar mass. And we have this many moles of the cobalt-2 nitrate hexahydrate. But we want moles of cobalt. Remember, there's 1 mole of cobalt formed for every 1 mole of cobalt-2 nitrate hexahydrate. So the units cancel out here. They don't change the number, but it gives us the units that we want. Now we have the top part of the definition of molarity, the moles of the solute. So plug it in. The concentration of cobalt-2 is the moles of cobalt divided by the liters of solution, and we get 0.1915 moles per liter, or if we just put a capital M, we say at 0.1915 molar, means moles per liter.